Yeah, we are live. What were we discussing today? We're discussing something about power, right, Eric?
Well, I'm curious because I think there were like these two tracks running independently, and now we've come to a milestone in the tracks, and then what happens next?
Did we do the third part for you, like about the design we were doing for Yakasaur, or did we have only 2 sessions?
No, we had three.
Okay.
Joshua is right. We're at the point of decision, but Venkatesh asked to be in when we bang it all together and come to some sort of decision. And we talked about Eric perhaps leading something about power. And as an alternative, you remember the natural robotics contest, which happened last year? So it's happening again this year. So we could, talk about group submission.
The Flux competition is also still live, and that could be something that the group enters into.
What is that?
The Flux
It's the
robotics design
PCB.
competition.
Yeah.
I'm not sure if I posted it. I think it was posted in the Discord that there was a competition. But anyway, it sounds like there wasn't robotics design competition.
When did you post it?
It would have been
Okay. Got it.
Oh, you found it?
Yeah. This one. Right?
Yes. Yep.
Oh, this is due in a month, 4 weeks.
Yep. A friend of mine is judging.
So what is a robotics PCB?
It is something that we have discussed in the Yakasaur track as a necessary subsystem component that would be greatly beneficial. I really see this competition as being in complete overlap and alignment with the natural robotics competition. I feel like the Yakasaur is very much in both. So effectively, it would handle things like power management. It would consolidate the power management problem, the lizard brain, and some of the basic I/O and peripherals.
I'm still trying to understand. I have the instructions on screen. What exactly we're supposed to be doing? Is this
For the competition?
For this competition? Yeah.
Like I said, I'm not completely. I don't completely get it either. I think at the core, we're to be building something cool in Flux, and that's robotics related. So this is something that I do think is well aligned with this PCB that we were discussing for the Yakasaur.
In other words, so if what we're going to do is design a PCB for a simple two-wheeled robot, That's what the competition could be about.
I mean, a simple two-wheeled robot, I'm not sure that fully captures the challenge. Like, what we need specifically is not available off the shelf exactly.
Simple two-wheel robot that can be dumped in the Mojave Desert and will still do something 24 hours later.
Well, hopefully 24 days later, but yes.
Yeah, but I'm talking about a PCB part of it, not the mechanical part of it.
Well, yeah, I mean, first one then the other. But I just
So Flex is a service for making PCBs. Is that where this is coming from? Like this is a get
Flex is a
educated about making
PCB design
PCBs.
tool. It's like it's like kind of a hobbyist level PCB design tool. It really isn't something for any professional work, but it's like kind of it's like a cloud collaborative KiCad kind of a thing.
Got it. So the idea for us to participate would be like take our PCB needs and just go ahead and do it as part of the contest. And
yeah, it's like we would design the PCB in Flex and build in public, and yeah, hopefully have a rover out of it. That'd be cool. Yeah.
And the full mechanical design isn't necessarily part of the contest, but it kind of like goes hand in hand with like
yes.
Yeah. It's a PCB for robotics, so you kind of have to have the robot part. They're just not judging that part.
Can we do it in 4 weeks?
I think so. I think if we keep it really simple, I think so. Yeah. It would require definitely more than 1 hour per week. It would probably require honestly, I think it would probably be if 2 or 3 people contributed 4 hours a week for 2 weeks, I think it would get done.
Even if we
but
didn't
it also depends on how familiar you are with the tool. Like I've never used Flex personally before. I've done plenty of PCB stuff and other tools, so I feel like I'd probably pick it up pretty quick. But there is definitely a learning curve on the tool itself.
Well, that's all positive. The only thing holding me back from saying, yeah, let's do it, is I have no image of what I'd be doing for 4 hours a week. In other words, I think it's great that we're designing a robot, and one of the questions is, well, we need a special PCB. So we're using a tool in order to design a PCB, cloud design a PCB together. Okay, and then people can see how we're learning how to use a tool and how we're designing it. I mean, that's wonderful, but I've just no feeling for what people who don't know much about PCB design will be doing for 4 hours a week. Can you?
I mean, there's certainly other things that would need to be done. It really depends what the like ideal output was at the end of the 4 weeks. It's like if there just wants to be a PCB design, that's fine. But if we also actually want to have like a robot demo, not necessarily deployed, but like hopefully running, because the thing is there won't be time to get the board produced and brought up and all that in this time. So the design would be done, but then the actual prototype, it's not going to happen in 4 weeks. It could be in fab in 4 weeks, but I think it would be very much like maybe we could have the breadboard bodge wire version running that the PCB is embodying, but not necessarily the full thing.
I'm looking at the instructions and I don't see, Anuraj, I'm taking over. Step 5 is routed. step 6 is get ready for manufacturing. You won't necessarily need to manufacture your boards and make your project public. We don't actually have to build it by June 4th. We can do that by ourselves after the competition.
Certainly, yeah. I'm just saying it would be cool if we did actually send the board to Fab prior to the end of the competition. But yeah, we don't have to. Like it would be good to like have here's the design. Also, it's on the way back. Because yeah, I would push for the design to be produced. Yeah, by the time it was entered, by the time the judging was happening.
What's your intuition on turnaround time for manufacturing?
If we go with like the really cheap, fast one, you know, GLC PCB is kind of the name of the game still, and that's like 5 to 7 days landed in the US.
Around 1 week, I would say.
Yeah.
But I'm willing to put in the 4 hours a week, but somebody's going to have to micromanage me, and because I don't know what to do.
I mean, one thing that still will be important. So if we're going to design a PCB, we currently lack the guardrails, I think, for the scope. So there still is definitely, we didn't fully get through any form of a sort of a spec or guidance document, or like, what is it quite? We have a sort of I think we do have maybe a collective consciousness of what the system block diagram looks like, what the actual system is. But in terms of like the nitty gritty and then making sure it performs the mission that we set out to do, at least from my perspective, I think the current spreadsheet that we've captured is not quite there. So that is something somebody needs to do, is like have a good think about it. And then I think maybe kind of crystallize that into an actual presentable diagram and presentable documentation.
Yeah, my follow-up would be, and not necessarily a question just for you, Joshua, but what form does that take? Do we need we tend to put everything in whatever the note-taking app is, but do we need a Word document? We just need a picture. What do we need to be able to feel like we're solidified on it? What does it look like?
Yeah, I guess my other question would be, what's the output in terms, because I mean, we certainly have these recordings and things, but will this be a blog post, a presentation at like kind of a Yakathon? What is the exhaust from this robot and PCB going to look like to be disseminated and discussed? So like if we are going to have a system block diagram and a story that kind of follows, is that going to be in, again, slides, blog post, talk?
GitHub repo.
Yeah.
Hopefully one that's well documented and has pictures that engages people. Yeah.
GitHub repos that also has a link to the Google Slides. Yeah.
This may be one way to split the tasks, because Flux and PCB development for me also very little experience, more like Meyer. And so if some people can take the Flux part and some other people take the GitHub repo design part and image and so on, we can craft something pretty well overall, no?
I think so.
This thing
Well,
is
the
really
problem is
slow.
these kind of like stacked together though. Like we need to even understand what it is that we're building before you can even do the Flux part. Although I guess there's a lot of education maybe that needs to happen first, but just like, how do we even communicate to ourselves what it is that we're building? That's more of a challenge than I think would have guessed going in.
Joshua, can you give us an example of what a spec for a PCB looks like?
That's actually, man, that is, there's no one answer to that still today. Like, let me tell you. Yeah, so very often how this goes and how I would suggest that we actually handle this, there's kind of two main inputs to the PCB. The first is the board outline and mechanical considerations. It'll come from the MCAD. So we'll like have the on-shape model of the robot that incorporates the PCB inside of the robot or adjacent or wherever it goes. And that will generate an actual outline of the PCB, which in the simplest case will be some arbitrary rectangle. In the not so simple case, it'll have holes and cutouts and random things, complexity on the edges. That's something that has to be defined on the mechanical side. And that is something we would import into Flux. And then we could begin, the actual routing of the board on that part. The second input, besides the mechanical form factor, is the system block diagram. So we need to generate a system block diagram showing the things that have to go on the board. So there's some stuff that will have to go on the PCB. And then everything will flow from that. So it'll be a system block diagram, and then that gets converted into a schematic, and then that schematic gets converted into a layout, and then we generate the board.
So yeah, in the Flux tool, so this is how the kind of schematic would look like. So once you know what components you, so this is the example I took from the same link, like competition link. So they have given an example board. I think this one is called ESP32 robot controller or something. So they have some links in the same web page. So this is what a schematic would look like. So what you would do is like place. So if you scroll in, so if you see, this is like the dev kit board. So each component would have certain number of pins. So you place this, and this has a footprint. So each component has a related footprint to it. And then
right. So that's very nitty gritty into the ECAD Flux tool. I'm just saying, what do we need to have before we can even start this part in Flux? And it's one, a system block diagram, and two, MCAD board outline. Those are the two things we have to generate first.
When you say system block diagram, you mean of the Yakasaur or you mean of the board?
I mean of the functional systems of the
board.
Yakasaur.
In other words, is a wheel part of that block diagram?
No, this is a electrical system block diagram. So I mean, ideally we would have multiple block diagrams. One would be system level, one would be subsystem level. But the one that I'm specifically referring to is the electrical system block diagram, which will incorporate things like the motors, the solar panel, the Raspberry Pi, the cameras, the power management, the motor drivers, all that stuff needs to be kind of like loosely laid out, with basically showing power and data connections between the systems, not at the actual physical wire level. Maybe I can find an example of something.
No, okay. We can do that today. Joshua, even after you go off. I think a block diagram showing all of the electrical components in the system is something that we can prepare.
I think that the other question was, are there decisions that we don't know how to make because we don't know enough about the mission, or can we just guess and move on and see where that ends up? Like, what microcontroller do we use? Like, I don't know. There's probably a lot of ways to choose between them.
This is what I would say and suggest. I actually think that what we're talking about is pretty interesting from a number of perspectives, which is this notion of having a low power, but high compute switchable, like consolidated board. Like this notion of having a big brain and a lizard brain, one that can manage the other, will be a pretty interesting thing to design. And because again, there is like this Raspberry Pi power management thing, but there isn't somebody who's been like, we built a board for a robot that's specifically designed to only have low duty cycle compute now and then. So this is sort of interesting in its own way.
How does that look in the block diagram? In other words, the block diagram, let me explain. In the block diagram, I have lizard brain, and I have big brain, and I have a component that's called switch. Okay, but there seems to be something else I need in the block diagram, or not? Is that the levels that we're talking about?
Yes, there would need to be effectively like, it's called a load switch. So we'd have a load switch in the system block diagram that's controlled by the ESP. Yeah. I'd suggest just go with the ESP32S3 or the C6, either of those. Those are kind of like the cheap and easy chip these days. Just use those. They have plenty of SRAM. I know Ranraj and I are talking about like not having much SRAM. That thing literally has, I think, 500K of SRAM. It's almost like a megabyte, which you can, lots of room for activities in there. You can run full Zephyr, no problem, all day long.
So you mean I don't have to page 60 bytes of image data from the image sensor to the radio and back and forth? I could use memory.
Yeah.
Cool.
But yeah, the block diagram is definitely the next step, because that'll make it clear what, like, one, what parts we need, and two, like that the board has to have those parts. Because we might actually find it'll be interesting to like, where do we draw where the board captures it? Because ideally there would be like, here's an example of some system block diagrams. If I present. Oh, this doesn't understand the notion of a window. Huh. Okay. Oh, no, it does. It's just a different UI. So this is kind of what I'm getting at. If we have all the components kind of drawn out here, then it will become clear where we would draw the PCB.
Yeah.
If you want to do something like this, you could, but ultimately this is more of what we need. I know it's not as appealing, but this is really what we need.
No.
That's not a good example. There's a better example. Yeah, this is a great example.
Same thing.
Yeah, this kind of a thing. All right, I do need to jump off though, but yeah, that's what I would say. I mean, do you guys think the flux competition is kind of interesting? And I think it would segue very nicely into the natural robot as well.
Yeah, I think it's interesting. Even if we didn't make a deadline, it's like that's the path we need to go on anyway. So
yeah,
we might as well try.
I've also wanted to try out Flux for, like hobby project reasons. I certainly can't use it professionally, but I'm excited to try it out. I think it'll be fun.
Why can't you use it professionally? Oh, you have to leave, but
just because it doesn't, it's just, there's just like a lot of things. Ultimately, it's more, there's not as much stuff to make sure there's not going to be errors, and it's slower. Those are the two reasons. So it's inefficient and potentially risky compared to a tool like Altium Designer. Yeah, like Altium Designer.
You're saying like the tool itself or the result that you get out of it?
Well, both, right? Because it's like there are fewer things. Like in my understanding, Flux does not have as sophisticated of design rule checks, which is
I see. Yeah.
That's like one of the key things you have when you're designing a PCB is their rules to make sure that the PCB is the copper is in the right spot, among other things. So it's like if you don't have the automated checks that you did before, there's higher risk that you'll release a board that's scrap, which is very expensive. I mean, it can be extraordinarily expensive.
Right.
So
not worth it in a professional setting, but for hobbyists, it's like, maybe it works, maybe it doesn't.
Yeah, for lower stakes boards, yeah, because it's like if it's there's an issue, it's not like we'll fix it and make another one.
Yeah.
But yeah, if you do want to see a tool like Altium Designer sometime, we could look at a tool like that and just kind of to compare what full flavor professional tool looks like versus something like Flux. But yeah, I'm excited to try out Flux because I personally drive KiCad and a little bit of Altium. I've never touched any of the Cadence tools, but I'd love to try Flux, especially as an Onshape user because it's collaborative, which I think is an important thing for PCB design. That's still not quite there. I keep joking. I hope PTC will acquire Altium, and then Altium will turn into Onshape side by side. But I'm not sure Altium is a thing you can buy these days.
Doesn't Altium already have some cloud tools? No, they have it, right?
Altium 365 is kind of cool, yeah, but it doesn't have like collaborative design in the browser. It has collaborative review and viewing, but you can't actually design in the browser. They did, I think Altium acquired a company called Upverter a long time ago, and then they kind of like stalled development. But Upverter, I actually never had a chance to use Upverter personally. Oh, I guess it is still around, but I don't know if it's actively developed. Either way, everybody who speaks of it says good things. I don't know who. Excalibur is great. Yeah, it's a great. You want to do the system block diagram in Excalibur? That'd be sweet. Yeah, that'd be really good.
Yeah, so that is what I was suggesting. We could do it there.
Yeah, Excalibur is super fun. But yeah, Upverter was like another collaborative design tool that was out, but I think it stalled. So now there's Flux. It's exciting.
Right, what do you mean collaborative design? Just a small question.
Oh, I just mean having the ability for multiple users to be editing the same design at the same time.
Okay.
That's all I mean.
Yeah, so I just signed up for Flux, and when I started, it was like, here's an invite to send to all your teammates, and so you can all get started on the same project.
Yeah. So like having multiple people working on the same schematic at the same time, collaboratively, the same layout at the same time, I think is kind of interesting, especially for this project. It's pretty cool because we can all kind of like, riff off of each other and learn. So it'll be interesting.
You also automatically have an AI chatbot in the chat, so you can just ask it to build the PCB for you.
They actually just added that like 2 weeks ago. Yeah. So that's like a brand new bleeding edge feature. Yeah. Yeah.
So I'll just say, build a PCB for a Yakasaur and see what happens.
I mean, it's just the, GPT-4 API. So
yeah.
Like it has context and, ask it questions about the design. I don't know. We'll see. But that could be pretty interesting. The collaborative PCB design is something that has shown up in other kind of like what I would consider to be old school tools. One example is Zukin. But Zukin Collaborative is like, you have to have like a Windows server like in your building, and you can only have like 5 people logged in collaborating on the same PCB. It's, you know, it's kind of like old school and crusty, but this is like an example of Zukin's MCAD collaboration. But Zukin also has ECAD, multi-user ECAD layout collaboration features as well. Zukin's kind of interesting because it's one of these like systems-based design tools, which is kind of like the ethos that I have when I'm designing products. I'm not a Zukin user. It's a little bit old school for our use, but it's pretty cool because you can actually design. I mean, you can see system block diagram, mechanical, PCB, all in one view, one software, which is still not a thing that's very common today. So in terms of like actually having the power to view a product from any dimension at the same time, it's a very interesting vision. But all right, I really am going to head off now. And yeah, the Excalidraw system block diagram sounds like a great next step. All right, thanks, guys.
Thank you.
Thank you.
Bye. We have some more time.
So let's try to design that block diagram. Do we have the Canva, Figma? I don't know what.
It's the tool I put in the chat. It's called Excalidraw.
When you say chat,
So there is a chat. There should be a chat screen, private chat. So there's comments and then private chat.
Yes.
But for Excalidraw, usually you have to create a board and then open it for collaboration. It's that link maybe we should share.
I've played with it, but exactly I don't know how it works.
At the top right, you have the people icon, and so you can open your document for collaboration. The top right.
You mean this one?
Yeah.
Probably you need an account for this, right? No.
It's I think it's local storage.
Okay.
Thank you.
Okay, and I need a name. Okay, I just added an element. Why don't you see it?
I can see.
I'm looking at Anuraj's screen. How do I add?
Can you guys interact with that square?
Yes. This one, for example.
Okay. Seems
Wait,
to work.
how come I see 2 motors on my screen, but I don't see anything on the Anuraj's screen?
What do you mean?
Maybe you need to scroll up or something. I see a camera, motor.
Okay.
Yeah.
Okay. Okay.
Okay. How do you add text?
Just double click
That
on
is
the object.
this
Yeah.
one.
Okay.
You click on this. If you
That would be.
add text, it will be a different object. If you want to add text attached to the form,
Okay.
to the shape, you have to double click.
Yeah, okay. I don't know what an ESP32 is. I know what a lizard brain is.
The microcontroller, that's the lizard brain.
No. I know, but if we're talking about motor, so the level is, we have a lizard brain and we have.
What's the right level of abstraction? I'm not sure.
And what did he say it's called? It's called the load switch. Okay, I don't know what's going on here. Undo. Where's the undo button? Okay. See, I'm not sure I agree with this description. Does the lizard brain support the motors, or does the lizard brain do something else? Yeah. And of course we have a battery.
So I put a link for the block diagram. So probably it has most of the things we need.
Yeah, but why are you assuming? Well,
Okay. You mean like it could be anything, right? You mean that
I
way?
have a lizard brain. Maybe it's made out of 3 ESPs.
Yeah.
But anyway, it's an MCU, right?
Yeah.
Yeah.
We have an MCU and we have somewhere a CPU or GPU.
Yeah, that's why we have the big brain.
And then we need GPS or GNSS,
What is a DNSS?
Global Navigation Satellite System.
Ah, okay. So in that case, we have a comm system.
Do we need 2 cameras?
Need? I just thought it would be cool, so I added 2. Because I can just copy and paste it.
Okay.
Might need one in the front and one in the back.
What sensors do we have?
So camera is a sensor, right?
Yeah, but something like humidity, temperature.
I would put in some ultrasonic. Yeah, but yeah, actually you don't need that because we already have the camera.
And a lot of these systems on a chip have like accelerometers built in.
Yeah. So the
And
IMUs.
compass. And the IMUs are built in.
Do we have a separate memory component, which is accessed by big brain, little brain, and so on?
If we want data logging, yeah, so we could put in a SD card there. Like, but depends how much data we want to log. Or it could be a SPI controlled flash memory or RAM. So you can just put in some memory there.
So it's interesting what you did again, you're assuming that the camera stuff has to go to the big brain, but Rhett showed us that the camera can just go to the comm system, maybe through a microcontroller, not I'm sorry, maybe through a ESP.
Yeah, so I think that's the question about just what is the value of the big brain in this
Oh,
case. I think we could actually do this fully without a big brain.
but you
at
want
all.
to have a big brain because sometimes you want to do local processing.
Right. And so if you do, though, that adds a lot of complexity to the design for sure. But probably at minimum, you're going to want the big brain to have access to the camera. I would think.
Unless the camera is somehow on a bus that goes somewhere else, a buffer. I mean, that's how people used to design it. Yeah, the camera connected to image buffer, and then you could read from the image buffer.
Yes, that's an interesting. That could be an interesting and relevant PCB design for robots, because I think that, for example, what you did with with your car, okay, where the camera was connected to an Arduino, right? Okay. And you could send the images to the network. Okay?
Yep.
And so that could be the lowest level. So something we want to be resilient to work, whether or not the big brain is on and off, or on or off. We're able to have this capability to have the raw images sent to the network. And on top of that, to have the capability to have an extra big brain that we can turn on and off depending on power management, to basically do extra computing on top of the raw images. So raw image MCU network, okay, that's a basic capability we want to be available. And optionally to add a CPU, okay, a big brain that could also do some local processing on the raw images to act on them or to send them transformed on the network.
So the addition of the big brain will depend, right? What sort of computation we actually want to do. Are you going to stitch them
So
together, or
it sort of sounds like what Eric described is the big brain is almost acting like an operator. So we
Yes,
could communicate to the microcontroller via the cell phone, or we could communicate, or the big brain can communicate with the microcontroller and do commands directly. Like we could say, as an operator, you could say, microcontroller, please send me the data from the camera over the cell link. Or the big brain could also say, microcontroller, send me an image. It's sort of like the same. It could be the same like protocol.
yes. And in terms of capabilities, okay, maybe to understand is that we could have the rover in it's for example, the rover detects there is no obstacle, okay, and the mission is to go forward, okay. Then just the camera, the laser brain, and maybe some proximity sensor, okay, are enough, okay. And at some point there is detection of an object, okay, and this is where the big brain is studied to do some object recognition on the image, to say, oh, this is a rock, or this is a wall, or this is a hole, okay. And turn off once the object recognition is done. So it's a fine-grained power budget management. I'm not sure how our own brain works on this one, okay? But we have our reptile brain, okay, that does a lot of processing for us, okay, including image processing. And it's only for some more kind of, into quotes, advanced capabilities that we call for the higher level brain, the neocortex and stuff like that.
I think the lizard brain is doing too much here. It's just a feeling.
It's going to be more critical than the big brain.
Maybe we
Because
need another layer. That's what I'm thinking.
Hmm?
Maybe we need another layer below the lizard brain, just like we have a motor controller. Maybe we have a video controller.
Well, the cameras themselves usually, or the one that I use, which is made as a Arduino cam or something, but it's the underlying chip has actually a fair amount of intelligence on it. Like it does the JPEG compression, like all on board and that kind of stuff. So it's not like a raw image sensor attached. It's like doing enough that you can talk to it via whatever the I2C or whatever the protocol is.
Yeah, but who talks to it? Who's talking to it? The lizard brain or dedicated, whatever chip?
Well, some component has to be able to talk to both comms and the camera, and some component also has to be able to talk to comms and some motor, or the motor controller.
Well, that's exactly.
So it's like there's always a shuffling. There's always a center that's like comms plus the whatever the thing you're interacting with, and then there's got to be somebody shuffling in between.
I'm agreeing with you, but there's a huge difference between lizard brain talking to motor controller and lizard brain talking to motor. The same way, instead of lizard brain talking to camera, lizard brain talks to camera controller, which could be a very simple chip that gets instructions either from lizard brain or from big brain and diverts, instructions one way or the other. Now, maybe that's making the design too complicated. I don't know.
It's modularizing it is what you're kind of promoting, I think. You've got intelligence spread out throughout the system.
Yeah, like a cockroach, yes.
Yeah.
But it also lets me make the lizard brain actually do lizard stuff and not just, let's call it cockroach stuff. That's why I'm saying maybe there should be another layer, not another chip, but motor controller, video controller, power management,
Well, let's try a different diagram then, or can we I can do this in just draft.
This is a draft. I don't know. Maybe can we save it as a name?
I think you need to create an account to save.
Actually, you can.
We can just make the diagram bigger and just do another one next to it. It's kind of like infinite canvas, right?
You can just select everything and just create another version that we hack basically, and we can name them. And also we can export to some specific format that we can save locally.
How big do we want the rover to be? Like, how big are we expecting? Is it the size like the rover Red has, or is it the size of the rover I have? Or
It's most likely something like the size of a shoebox, no?
okay. So we could have like two types of cameras, one which is attached to uh, the heavier computing load module, and then the simpler camera to the lizard brain.
Yes.
There should be.
Actually, maybe every camera needs its own camera system. You just want to speak to the camera over whatever protocol. Cockroach protocol.
What is this ULS? Ultrasonic.
Yeah, ultrasound.
Why a mic? So,
If it's stuck, it can call out or play some sound.
but so we are not in space, right? Because in space, usually sound doesn't
We're in the
propagate
Mojave
quite.
Desert.
Well,
No,
yeah. So
the
it has to be on Mars, at least. It cannot work on Moon.
yeah, my understanding of the competition is that it's a space themed. Okay, so that's why.
No, it's robotics. I didn't notice any space.
No, but we can submit anything, right? To the competition.
Okay.
I
No, sure.
Does it specifically say space in that competition?
Competition
There's robotic space.
instruction,
It's just,
robotic design. No, it's robotic space. In other words, it's a field of robotics. It's not space robotics. That's why they give examples of saw and so on.
yes. Okay.
But Mars has atmosphere, right? So sound, ultrasonic things should work there.
Yeah, junky, but yeah.
Oh, then one thing that I think personally at my level on PCB design and so on, I would say simpler is easier. So for me, removing components is also a good idea. So you see, for the camera system, okay, so the component between the actual camera and the MCU, it's it sounds like a driver, okay, but maybe also is there a way maybe to on the layout to explain more what it does, okay? Because it seems to me that we were, but once, for example, okay, is that what would be interesting is that the MCU basically asks for the camera system to get an image, but the default behavior would be for that camera system to grab the the raw array, okay, and to put that on a kind of shared memory, okay, and at some address, and that's what it does. Boom. And after the lizard brain can access it, but also the big brain can access it, okay, like a direct access to memory, to shared memory. Lizard brain maybe to do raw processing, that is, for example, just to forward on the network, okay? And the big brain, for example, to do some more advanced processing, okay? So to transform the image in that dedicated memory. So perhaps that's what
you mean that like metaphorically or like literally?
literally, I mean, you know, what we're doing now reminds me the architecture of the Commodore Amiga. Okay, the Commodore Amiga had, you know, it had its motherboard. Okay, but it has several. I think it has, depending on the model, but it has several, 3, 4, maybe up to 7 secondary boards. Okay, so when you buy the computer, it's you buy one computer, but it was architected with several boards, basically, not like we have most computers done now. Okay? And but back then it was pretty unique kind of design, if I remember well. Okay? And each of these secondary boards, they had a dedicated functionality. Okay? But all together, they were in concert. They were doing something pretty great at the time. Okay, and the thing that I remember they had some tricks in the design, the architecture. Okay, so that the different subboards could do processing on data in an efficient way, basically. Okay? And so it had a lot of advantages, I think, that have been reused in the later generations of computer design. Okay, but also in different ways as well. So here we are talking about a dedicated PCB for a robot, an autonomous robot and so on. So it sounds like to have a specific design that is tailored for the intended use makes a lot of sense. So here the example is to have a dedicated component, which would be some kind of working memory, okay, on which the different orchestrator, especially the lizard brain, okay, would just say, okay, this time we want imagery, so we ask the cameras to put, it's kind of blackboard basically. Okay, let's put some raw data on the blackboard, or to ask the mic to let's record some data on the blackboard. After, what we do with it is the next step. Okay, it's either it's no processing and we just forward this to the network, or simple processing or more advanced processing that will involve the big brain and stuff like that. So that's orchestrating the different components. Basically.
Yeah, I'm still
Not
not
sure.
getting like what's the use of the big brain. Because all of this thing can be just done with the lizard brain, the movement and stuff, and
So
also the position can be reported back.
No.
one simple example is, for example, not simple example, but okay, let's take what Red did. Okay, we're using only a lizard brain. He could do some navigation and to send the data, send raw data and so on. Okay, and but for example, I don't think it was feasible just with the MCU to do, for example, object tracking. Okay, or for example, or to say, okay, let the rover find a red object autonomously in the room. Okay.
I think ESP could do that.
What can do that?
The
No,
ESP32.
but not if you want to put in anything complicated.
Yeah,
Not
so
if you
like
want to run a complicated program of any type.
Yes, that's. It was just a simplistic example. I mean, to do some object recognition. Okay. So maybe not a red object, but for example, to find the cat, in the house. Okay.
I
So
think a lot
yeah.
of basic OpenCV style
okay, yeah.
functions work on like these lighter weight microcontrollers. Like I think we'd be surprised at how capable they are at some tasks, but it wouldn't necessarily be easy to work with. So I think maybe the big brain is like, here's the easy to work with platform. And in fact, something even simple like, do we want to change the software on the fly? You would need something to reprogram the microcontroller. So like the big brain can literally rewrite the software running on the lizard brain, or you have to have two lizard brains that can overwrite themselves each other to like.
Yeah, so there are ways to
live patch
over
itself.
over the air update, but then it just becomes complicated. We have to use some tool. Yeah, so we are at 1 hour now. But I think we can export this image and then continue next week, right?
Yes.
Sounds good. I like this StreamYard platform.
Yeah.